Hi folks, so today what we're actually going to be doing is another surface geometry question, and specifically another transition piece. So we can obviously see the question that we're given here, so I'll just read a little bit on the question. It says up here, question 1, the projections of a transition piece are given. So we've got the elevation and the plan view. We've obviously got a pictorial view over here. Complete a one-piece surface development of the transition piece. Now we have done questions very much like this in previous questions, only the shape you can see that we're given here is very much irregular. We can see obviously the base of it is circular, okay, and the top of it is rectangular. However, it is sloped up here. So straight away, when we know we're doing a surface development, we have to work out our various true lengths to be able to complete it. And like other questions that we've previously done, what we're going to be doing is we're going to be using the triangulation method. And I have explained that in previous questions, so I'm just going to get started, and I'm going to start locating, first of all, some various true lengths and splitting up my circle down here in plan. So I'm just going to do that there, dividing it up into 36 degrees. Okay, now that we have that split up into 36 degrees, what I'm actually going to do is I'm going to label it in plan view first and then label it in my elevation. So starting at the rectangular section here, which is the top surface, which we see as a line in elevation, I'm going to call this A, this corner B, C and D. And if I label it in plan, label in elevation, so A is at the front as we see it, so A will be there, D is at the back, and then we've got B at the front and C at the back. Okay, now I'm also going to label it down here in plan. The circle, sorry, so corner or point 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 12 back to 1. Okay, wherever those points are in my plan, I need to project them up to my elevation. So 1 should work out right there, 7 already there. Now 6 and 8 are in line with each other, as are 5 and 9, 4 and 10, 3 and 11, and 2 and 12. And once again, labels. So we had 1 here, and at the front then we go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the reason I put the 2, 3, 4, 5, 6, 7 all here on the bottom is because they're the ones that are actually at the front as we're looking in from this direction, whereas 8, 9, 10, 11 to 12 are all at the back as I'm looking here in the direction of the biro. So that's why they go at the back on the inside. Okay, now at this stage, because we know we're going to use the triangulation method, I have to create my various triangles. So like in previous questions, we have done this before, so I'm going to move on with this fairly quickly. So from each corner of the rectangle, I'm going to join to my various main points of the circle. Now, with that done, if I have it done in plan, I should also do it in elevation. So A joins to 1, D joins to 1, already done up here. However, A also joins to 4, and D also joins to 10, so that will be seen as one line in elevation, which would be there, like that. Same thing, B to 7, already done, C to 7, already done, but C joins to 10, and B also joins to 4. So at that point there, we have everything kind of up to date so far before we move on to the next part. Now, just to explain that a little bit further, we can see we've got a series of triangles. I have a triangle AD1, I have a triangle AB4, I have a triangle BC7, and I have a triangle CD10. And they are all up here as well. As we can see, there's one pretty obvious one here. It is AB4. So we can see that triangle here in elevation, and that is also a triangle at the back of it, which would be CD10. Now, just to use the 3D graphic over here, if I was just for purposes and we can kind of visualize it a little bit better, if I was to show you where 1 to maybe 7 is over here, if we imagine that point there is, if I was just make a little bit further mark, and I'm trying to do it as accurately as I can, if that was 1, then I'd have 2, 3, 4, about there. So if I was to label that 1, 2, 3, 4, 5, 6 and 7. Okay, and if I have it labeled down here, obviously we can imagine that circle, or the base of it, is back there like that, something like that. Now, if I have it labelled the bottom of it, I'll also label the top. So this corner here was corner A, this was B, C and D. And just for the sake of showing you kind of this section of it here, so 4 joins to B and a joint to A. So at that point there, 4, which was right here, I'm going to join that up to B. And I'm also going to join it to this corner here, A. And A, we know, also joins to 1, which joins to B. So if I was to do that as well. Now that's probably as much as we can kind of see on the pictorial view here. But it's very important to recognize, let's just take the triangle AD1. So we can see it here, AD1. In this view we see it as a line, but in this pictorial view we can see it, AD1. Now if you actually look at it, you can see that that is actually a flat surface, so it is. So it's very important to recognize that is a flat surface. And it's also, if we look at AB4, so it goes, look, when we're looking down top of it, AB4, that is actually another flat surface. The areas that we're going to struggle with on this question is actually the bits where it's going to start to curve. And that's in these sections here. You can see here 1, 2, 3 to 4, 4, 5, 6 to 7. In these little sections in here. There, 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 and there. So if I was just to highlight them, you can actually see, if I just kind of, as best I can, that's actually the curved bit there. And this bit here is also the curved bit. No, excuse my sketching and my kind of lines and my shading, but they are the curved sections. And what we have to do is we have to create the lines connecting them using the triangulation method. So from A is going to join to 3, and it's going to join to 2. And what we need to do, and it would be the same over here, B to 5 and B to 6, but we need to basically get the true lengths of all of these lines here. And when using those true lengths, we're then going to develop it out using the true shapes. So at each corner, I'm going to join them up now to their little sections. So A is going to go to 2, 3, and so on. Okay, because I had it done in plan, I'd also put in those lines in elevation as well. So, to start this question now, what we actually need to do is we need to work out our various true lengths. And straight away off the sheet, what I want to work out is, first of all, the base. It's a circle. Now, obviously, we cannot measure the circumference of the circle with a ruler, so what we always do there is from 1 to 2, that's sitting on the ground. I can take the distance from 1 to 2 on my compass, and that's a true length. So that's the base of it taken care of there. Now, A, B, C, D, A, that rectangle there, we have to work out what lines on that are my true lengths. Now, as I look down on top of it, or I look in at the elevation, B and C, B to C is a line. And in the line B to C, we can see it here in plan, but in this view, in the elevation, we see it as a point view. That means it is running parallel with the floor, with the ground. So B to C is running parallel with the ground. That means B to C in my plan view is a true length, which is the same as A to D. Now, C to D and A to B are not true lengths in plan. A to B is not a true length in plan, but because it is parallel with the XY line in plan, that means A to B in elevation is actually the true length. So it's very important to recognize A to B in plan is not the true length, but A to B in elevation is, as is C to D, or D to C, however you want to call it. Okay? Now, with that worked out straight away there, the last thing we actually have to work out is the various true lengths of these lines here. Now, also important recognizing the geometries that are similar. A to 1 is the same as D to 1. A to 2 is the same as D to 12. A to 3 is the same as D to 11. And A to 4 is the same as D to 10. So once I've worked out the true lengths of A to 1, 2, 3 and 4, that means I've worked out D, 1, 12, 11 and 10. Vice versa on this side, B to 4 is the same as C to 10. B to 5 is the same as C to 9, B to 6 is the same as C to 8, and B to 7 is the same as C to 7. So once again, as I've worked them out on the B part here, then I've worked out all the C part as well. Okay, and after that we just build it up. Okay, so what I'm actually going to do is I'm going to use the cones method, cones analogies, of using the apex of a cone and to work out the true lengths by getting the extreme generator. So if I was to take A as the apex of my cone, what I would do is, and I want to work out the true length from A to 1, okay, and for the sake of it I'm not going to bring it in here because it'll get too messy, so I'm going to keep it out here. So if I extend a line out there, and if I want to get the true length of A to 1, because when I look down on top of A would be the apex, but it would also be the center, and 1 would be my radius, because that's where it is on the ground. So, where 1 is there, I'm just going to rotate that around, and it's there, and that's my point 1, which is just basically moved from this position, a generator moving around, it's moved this way, okay. And if I have it done in plan, I need to project it up to my elevation. And you remember 1 was always on the ground, so literally 1 has just come from here and it's moved all the way out here. Okay, fill that line so we can see it a bit better. Okay, and that is my 1. Okay, and what I can do with that is I can join it up to my A. And because that is the extreme generator of a cone, and when I look at extreme generator of a cone and we can see it's parallel with the XY line, that means in my elevation, that line there is my true length. Okay, very important, that. So, just put that in heavy, that is my true length from A to 1, which is also the same as from D to 1. So I've got 2 true lengths there. Now I want to work out A to 2, A to 3 and A to 4, all using the exact same method. So here's A to 2. Do the same with A to 3. And I'll do the same with A to 4. So this true length is my A to 2. Just put in that a bit heavier there. The next true length out here is my A to 3. And then the next true length is my A to 4. There we go. A to 1, which is this one, A to 2, A to 3, A to 4. So I have 4 true lengths worked out there. Now I have to do the same with the opposite side. Okay, the exact same thing and the exact same method I'm going to do for B. So these are going to be a little bit shorter. So extend them out there. Extend it out here. I'll explain the first one, then I'll fast forward. So I'm going to get B to 7, which is the same as C to 7. That's the true length from B to 7. Now I'm going to do the same from B to 6, B to 5 and B to 4. Okay, now at this point I have all my true lengths worked out. I can actually start the surface development of the problem. So I'm actually going to start with the triangle AD1, and I'm going to pick a point out here that is my D. Okay, so I've got to get the true length from D to A, and then D to 1 and A to 1. Okay. Take the true length straight off the sheet. There's D to A. Go a little bit further. Straight away, always label, very important. Now I want to find A to 1, which is the same as D to 1. So I just need to get the right true length up here, and I can see it's my second one in. So just make sure you have it labelled properly. There we go. And A to 1. D to 1. There we go. There is my 1. Straight away, join it up. We tick them off as we go. That is this section ticked off. Now, what I'm actually going to do is I'm just going to explain kind of how to get as far as this far, and then I'm going to speed it up. So I'm going to do 1 to 2, 2 to 3, 3 to 4, which would be the same as D to 12, D to 11, D to 10. And at that point then I'm going to speed it up. Okay? So, now I want to find A to 2. Because I've got A to 1, now I need to get this little section in here. Okay? So, straight away I can take the true length from 1 to 2 on my compass, that distance there, which is the same as 1 to 12. So I'll mark it both sides. Somewhere along that arc is 12, somewhere along this arc is 2. And I want to take the true length from 8 to 2 then, which is the first one I found, and the first one I can see here. And from A, mark it off, that'll be 2, and from D, that'll be 12. Once again, label. Okay, now I want to get from 2 to 3, and 3 to 4. 2 to 3, which is the same as 12 to 11, so put it on 2. Swing an arc, somewhere along that arc is going to be 3, and put it on 12, and somewhere along that arc is going to be 11. Now I need the true length from A to 3, which is going to be the same as D to 11. So put it on my number 3, which I labelled previously. Put it on D, which will give me 11. Put it on A, which will give me 3. Once again, label 3, 11. And then we find the last one, which is from 3 to 4 and 11 to 10. There's 3 to 4. And then 11 to 10. And we want to get the true length from 8 to 4. Just the one on the outside, up here. Take that, and at A, make a little mark, and at D, the exact same. Worked out neat and tidy there. So that is 4, and that is 10. Now, at this point, I'm going to join them all back to their respective letters. Okay, and I will start to put in the curve as well. This part is obviously curved due to the fact that the base is circular. Now, I've done these three here, so I can tick, tick, tick. On the day you're doing this in an exam, you wouldn't tick. I'm just doing it for the sense of I know what I've done as I'm going along. Now, the next part I have to get is A to B and B to 4. Or sorry, A, B, 4 triangle, and I have to get to DC 10. I'm just going to explain one of them and I'm going to fast forward it. Now, if you remember, A to B is not a true length in plan. This distance right here, from A to B here, is not the true length. It's actually the true length up here. So I need to take it from the elevation. So at A, I'm going to take the true length for B, which is the same as D to C. So at A, somewhere along there, that arc is going to be my B, and then the same with D up here. Somewhere along that arc is going to be C. Now I just need the true length from 4 and 10, because I have 4 and I have 10, so if I get the true length from 4 to B, then that would be able to find the exact point of it, which would be the same as finding C up here. So I have to find which one ever it is over here. So this is my second one in. So at 4, mark it off. It's gone slightly into my drawing, not a big deal. And there we go. And at this point then, I have now found B and C. Join them both back. And at this point, once again, you can see I've ticked off this one and this one. Okay. Now at this point, what I'm actually going to do is I'm going to speed it up, because you can see I just have to get this section here, 4, 5B, this section, this, and then the last triangle BC7. Okay. Right folks, that there is the completed surface development of the transition piece here. As you can see, it was a fairly irregular piece, but once again, very much like other questions that we've previously done, it was literally all about obtaining the true lengths and recognizing the tricky parts and what was similar in the question. So triangulation method, we split it up down here in our plan, or whatever we split up down in plan. We also had to find an elevation, and you can see we found the various true lengths of all of these lines here, which were these marks here, these triangulation lines from B to 7, which was the same as C to 7, and so on the whole way around it. As you can see in the explanation over here, you can see the section that you're always going to struggle with is these curved parts here, because we do have some plane faces on it, some flat faces, which was here and here, but these curved parts here are the tricky bits. Okay, I hope you found that helpful, guys. Once again, very similar stuff that has come up previously, but very, very important, and the fact that you have to understand how to implement it. Okay.